In this example, we're going to do a word problem related to the mean value theorem. So the mean value theorem, just a quick refresher, is we are going to try to figure out, as long as a graph is continuous and differentiable, we should be able to find the slope between your endpoints. And whatever that slope is between the endpoints, there should be some point somewhere in between that also would have that exact same slope. We're going to use that idea on a word problem. So the situation is the lapse rate is the rate in which the temperature decreases in the atmosphere with respect to an increasing altitude. It is typically reported in units of degrees Celsius divided by kilometers and defined as a negative change in temperature related to altitude. When the lapse rate rises above 7 degrees Celsius per kilometer in a certain layer of the atmosphere, it indicates favorable conditions for a thunderstorm and tornado formation, provided other atmospheric conditions are also present. So here's our situation. Suppose the temperature at 2.9 kilometers is 7.6 degrees Celsius, and the temperature at 5.6, so we went up, has dropped to a negative 14.3. So that's quite a bit of a drop. Assume that there's also temperature function. Assume also that the temperature function is continuous and differentiable. Means we have a mean value theorem at all altitudes of interest. What can a meteorologist conclude from this data? So we're going to do a visual because I don't have an equation associated to this. So the best I can do is a visual. And so my X value is going to be my kilometers, right? Because it's the change in temperature related to the change in altitude. So we have kilometers, and then we're going to go, we're going from 3 to about 6. So I'll just go by 1. So 1, 2, 3, 4, 5, 6. Okay. And then our altitude, our temperature is, we have 7.6 and a negative 14. So let's say we'll go by 5s. So we'll make that a negative 10. That's a 0. And that's a 10. So we're looking at a negative 15, negative 5, 5. And that's our degrees Celsius. So let's plot some points. So we have almost a 3 and a 7.6. So somewhere up here. And then we have 5.6 and then a negative almost 15. All right. So what I don't know is, I know these 2 points, the idea is that it's continuous and differentiable, so they can connect, but I don't know how they connect. And so I'm just going to make something up because I really don't know. We'll say this does something like this. Okay. So basically we want to see if somewhere within that altitude, do we have some sort of a drastic degree change? Because if you have a drastic degree change within a certain altitude, that's when you have these favorable conditions for thunderstorms and more importantly, tornado. So all we have to do for us, this mean value theorem, is if we take these 2 points, figure out the slope between them, and if that is something that's bigger than this, then somewhere along that has those favorable conditions, just with that little bit of information. So all we need to do is figure out our slope. And our slope is going to be basically this coordinate, so negative 14.3 minus 7.6 divided by 5.6 minus 2.9. And if I throw that into a calculator, that gives me a negative 8.1 degrees Celsius per kilometer. So, which is bigger than our 7-degree change that we have. So somewhere in here where these potential steepnesses are, there is favorable conditions for a tornado formation to happen, right? And so that's kind of us using the mean value theorem for that. And so if the real situation was, this was data taken from an actual situation, and it says that meteorologists look for these steep lapse rates in layers of the atmosphere where the pressure is between 700 and 500 hectopascals This range of pressure typically corresponds to altitudes between 3 kilometers and 5.5 kilometers, which is kind of fitting our range right now. And it says in this example, were recorded in Denver, and at a nearby same time, a tornado struck 50 miles further north. So that data was real life, and that data actually did imply that there was a potential for tornado formation, and it actually happened. So that is a rough idea, especially trying to figure out a mean value theorem of how it could work kind of in the real world, where we don't necessarily have equations, but we can figure out certain situations based on the mean value theorem.